In section 5.2, we study infinite series. So it's related to sequence, but you need to distinguish, okay? Sequence is a list of number. Series is related to the sum of that list of numbers. Okay, one is a list, another is a sum, so they're different. So let's look at the definition. An infinite series is an expression of the form. So what is an infinite series? You have a list, is an, and then you add them up. This symbol is sigma, but the operation is you add every term up from n equals 1 to infinity. Now, how do you express this operation? So when you see this expression, it's just telling you what to do. You say, okay, write A1, you add to A2, you add to A3, and so on indefinitely, right? So that is an infinite series. Now, if you consider partial sum, okay? So partial sum. So what that is S sub k. Okay, what is the partial sum S sub k? It's saying, okay, n from the first term all the way to kth term of an. And if you express that operation, it's just a1 plus a2 plus a3 and so on, and you stop at a sub k because you sum up the first k term. So then S will be a list of number, right? So those partial sum will give you a list of number S sub k. And that list is a sequence now, okay? Every time we have a list of number, is a sequence. If the sequence of partial sum converge to a real number, what it means is limit as k goes to infinity, S sub k will equals a limit. Then what we say, a limit, this time don't confuse you with the limit of a sequence. We call that limit S, okay? Capital S. It converts to a real number S. Then we call the infinite series converge. So we will say, okay, if the partial sum converges, then the whole entire infinite list, when you add it up, it should equal this number. Okay? Otherwise, if the sequence of partial sums diverge, then we have a divergence of a series. So if S is a real number, then we call the series converge. Otherwise, it's diverge. So how to understand this definition? We will need to take a look at some example. So example 5.7. And I also encourage you to follow the link in our textbook to take a look at the media, okay, website that shows a whimsical approach to Siri, okay? If you are not quite sure, not quite understanding the definition. So let's take a look at example 5.7. How do we evaluate limits of sequence of partial sum, okay? So A, we have a series n from 1 to infinity. So this is a sum. It might equal to a real number or it might diverge. So how do we examine that? We have to take a look at the sequence of partial sum. We need to look at this sequence. S sub 1, when n equals 1 is just 1 over 2, right? S sub 2 is f sub 1 plus the next term, right? A2, what is A2? 2 over 3. And S sub 3 is the previous answer, right? So it's S sub 2 plus A3, which is 3 over 4. So what it is, this is A1. So A1 plus A2, and S sub 3 is A1 plus A2 plus A3, and so on. So what do we notice? We notice that each term added is greater than 1/2. So this is 1/2, but every time you add a new term, it's always greater than 1/2. Why? Well, n over n plus 1 is very close to 1. So it's always greater than 1/2 because it's closer to the one side. So what you can do is, so S sub 1 equals 1/2, but S sub 2 is greater than 1/2 plus 1/2, which is 2 times 1/2. And S sub 3 is greater than 1/2 plus 2 over 3 is greater than 1/2, right? And 3 over 4 is also greater than 1/2, which is 3 times 1/2. So what we have is this sequence S sub k is always greater than k times 1/2. So that sequence is unbounded. And any unbounded, so the sequence S sub k is unbounded. Why? When k goes to infinity, S sub k is greater than infinity. So it's unbounded. So this series n from 1 to infinity, n over n plus 1, diverges. And it will make sense because every time you add a term, as n goes to infinity, every time you add something, you're adding a number that's very close to 1. So it's kind of like adding 1 many times. So you get a divergent sequence, a series. So that's part A. Part B. This sequence, what we have is a series. What we have is n from 1 to infinity, -1 to the nth power. So we have to write the sequence of partial sum. So this sequence S sub k will equals, when k equals 1, we get -1. The next one is -1 plus 1, so we get 0. The next one is 0 plus -1, right? So -1. And then the next one is -1 plus 1, so you get 0, and so on. So we know from calculus 1, this sequence, this list of number doesn't converge. Why? Because we do not have a limit. So limit as k goes to infinity, S sub k does not exist because it's alternating between -1 and 0. We cannot find a number such that all the terms are within epsilon away from that number. Okay? So that's part B. Part C, we have this series, n from 1 to infinity, 1 over n plus 1. So you can follow the idea in the textbook, right? But for me, I actually learned about this either in elementary or middle school. Is if you write out the term, it's just 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 and so on. So what you get is, okay, what is 1 over 1 times 2? If you break it into two fractions, it's 1 over 1 minus 1/2. And here is 1/2 minus 1/3. 1/2 minus 1/3. Common denominator is 6, right? And then 3 minus 2 is 1. Okay, so it's 1 over 6, right? So similarly, 1/3 minus 1/4, and so on. So what you see is that these two terms cancel, those two terms cancel, and so on. You keep canceling. So what is left is just 1. So because of the sum equals 1, it converges, right? But that's one way to find the sum of this series, like find the limit of this series. But we still should follow the textbook, okay? Because not every series you can cancel terms. So what you need to do is just follow the textbook. So what we would have to do is you still write out, okay, what's S1? It's 1/2. What is S2? Is 1/2 plus 1/6, which is 2/3. S3 is 1/2 plus 1/6 plus 1/12, which is 3/4, and so on. You see, that list of number, okay, this list of number is getting closer and closer to 1, okay? Or you can even have a formula for Sk based on the observation. S1 is 1 over 2, S2 is 2 over 3. We can conclude that Sk is k over k plus 1. Then we just take the limit as k goes to infinity s of k. That's the same as limit k goes to infinity, k over k plus 1, which is not infinity over infinity, okay? It's, you divide top and bottom by k, 1 over 1 plus 1 over k, so it's 1. Because that limit equals 1, based on the definition, right? That limit is your s. Based on the definition, this series equals f, which is 1.